Please introduce yourself and briefly summarize your education and professional background, including your role at EagleView.
Okay. Hey, Todd. I'm Piers Dormeyer. I am currently the CEO at EagleView. Education background, I'm an engineer, recovering engineer, but I've done an awful lot of other things along the way. But lots of experience across construction, engineering, insurance. At EagleView, one of the fun parts of the job is we get to do a lot of different things with a lot of different industries and people.
Okay, so please briefly describe what EagleView does and specifically how it relates to those infrastructure and engineering professions you just mentioned.
Sure. So we're in the business of asset intelligence. And what that means is we capture this high quality, very high resolution aerial imagery data from various sources. So fixed wing airplanes, drones, you name it. And we're always testing out new sources. And really what we do is we capture, we process, and we then can use that rich kind of base layer of data to create different solutions, different derivative data solutions. Some of that can be extracting information from that oblique imagery so that you can better understand your risk. You can understand change, for example, with the impact of change, asset inventory, people, places, things across, I don't know, thousands of different use cases. But it really all starts with this base layer of very rich data.
I mean, you mentioned oblique imagery. Can you describe how the different types of data are more relevant to certain types of applications?
Yeah, absolutely. So if you're used to looking at a satellite image, you're used to looking at a Google Earth image, for example, what you're looking at is ortho, right? Orthogonal imagery. Most of your viewers are going to know what we're talking about here. Top down, 90-degree angle imagery. So that's really, really excellent for lots and lots of use cases. But we capture a ton of that as well. Varying resolution, that's the level of detail, what you can see. But we also capture oblique imagery, which is imagery that is taken at an angle. And generally, that's when you're going to need a different type of capture platform. So an airplane flying at 5,000 or 10,000 feet is going to be able to get that 45-degree angle of a structure, for example, and you're going to be able to see the elevation details of the building. You're going to be able to see things like windows, your doors, and it's going to provide a whole lot more context for certain use cases than a simple satellite top-down image. So if you're interested in, if you're a utility and you're interested in vegetation management on your distribution lines, you're going to find that oblique angle is going to be really helpful because you're going to see the nature of that encroachment much clearer. And then as the resolution gets better and better from a typical market typical 6-inch down to something like what we're flying now, sub 1-inch resolution, you're talking very high res. You can see all kinds of details up to and including even like lean and wire sag and things like that.
Drones are a relatively new addition to the arsenal. Can you talk a little bit about them and how they've been incorporated in the program and what they add beyond the imagery products?
Yeah, so the drones, it's just one of those. I always use the toolbox analogy, right? So different tools for different jobs. When we're flying airplanes, we're capturing larger AOIs, large areas, much more efficient for us. For example, post Hurricane Milton, to get over St. Petersburg in a fixed wing aircraft, so that we can get data for a wide area in the hands of the folks that need it very quickly and efficiently. If you were trying to do that with a drone, for example, you're talking a lot of battery changes and driving all over the county in generally dangerous conditions. So that said, but there's a lot of cases where you absolutely need to do a detailed inspection on a particular structure or object, a tower, a building, a homeowner's home, and you're inspecting, for example, for maybe roof damage or something along those lines. And in that case, the drones are fantastic because they're going to give you this level of detail, and then you can start to use lots of other technologies like computer vision, machine learning to help you actually scan through that imagery and find the defects, find the anomalies very quickly and efficiently.
So it's pretty evident that natural disasters are now becoming worse and causing greater devastation. And one of EagleView's core products and programs helps aid disaster response. Could you describe how EagleView helps in this situation and what it does with its disaster response program?
Yeah, you got it. This is a big part of what we do, and something really important for us and our customers. But we call our disaster response program DRP. Wait for it, disaster response program. Um, and effectively what we're doing is to take an example like a hurricane, we're really mobilizing on those events in which we're expecting widespread damage. You have counties, you have public safety that really needs to get their arms around one of these events very, very quickly. But there's multiple stakeholders that care about this data. And ultimately the response and how we do it really depends on the type of event that we're talking about. Hurricane is going to be different than a wildfire, different than a tornado in the Midwest, for example. But essentially, what we're doing is usually in the case of a hurricane, we've got a fair amount of notice. So we're bringing together a team that is really that are experts at this type of operation mobilization. We're pulling in meteorologists, we're pulling in geospatial experts. We're trying to determine what the right bases are for us to get close to that storm, and we can get in the air just as fast as we possibly can, which may mean that we're putting people into disaster zones with drones so that they can get up very quickly. We're thinking about things like getting under cloud cover so we can get clear imagery, and we're also thinking about places that we can get the data processed, uploaded, and then published very, very quickly, even in situations where we might not have power. So there's a lot of considerations that are taken into consideration here, and things like storms, especially like wide storms like Helene, that we're just wrapping up a lot of that response. A very, very, very difficult thing to do consistently, effectively. A lot of coordination, a lot of professionals that are frankly really good at this stuff.
Could you help work me through what's a typical workflow for a disaster response situation, kind of from both the responder's viewpoint as well as EagleView's? If you just kind of walk me through a typical process.
I'll start with what we would do. I mean, we would identify that this is something that would qualify, an event that would qualify for that type of response. So, what would qualify? Well, generally speaking, it's the type of event. Just using hurricanes as an example again, is this a large enough event that it's going to impact a densely populated area or infrastructure, and is it likely to do significant damage? Is it something that everyone's materially concerned about? For example, the storm that just came through and impacted Sarasota County a few weeks ago was very different than I believe Leslie, that came into a fairly lightly populated area in the Big Bend area, the armpit of Florida, so to speak. So those require very different levels of planning, coordination, and frankly response. But it really starts with that. It starts with understanding the impacted areas, the projections. We're meeting as a team, often multiple times a day. We are meeting multiple times a day. The frequency increases as we get closer to impact and then post impact. And then we're looking at what is the equipment, what are the target resolutions and the captures, and what are the things that we're trying to solve for, and who are the folks that we need to get the imagery to the fastest. So we're lots of communication with not just internally with the pilots and the tech side of the business and the planning side, but also our customers. What are you worried about? What do we really need to deliver, and how do we need to deliver that? So that's really important. And so that regular communication happens up until the point where we're getting cleared for takeoff, and then we're up in the air, we're doing our thing, and then we're just processing that out to hopefully conclude with a successful and very, very rapid delivery of imagery to the people that need it. On the other side of the coin, on the workflow side for our customers, and this is a tough one to answer because there are just so many different call it clients or recipients, again stakeholders that really are trying to get access to data imagery, be it from a drone if it's some kind of inspection, or from the planes for the aerial imagery. So, I mean, you've certainly got first on the site are the public safety people. They need to get an understanding of what they're dealing with. They're going to want to understand, what are some of the areas that are difficult or dangerous to access. So, to whatever degree we can get them imagery so that they can understand where they need to kind of respond first. This was a really difficult situation in areas like Maui, where you just had a loss of human life and a lot of considerations. So getting that data in the hands of those people is really critically important so that they can start to make those dispatch decisions and whatnot. So that workflow, then they take it into their own internal workflows and start dispatching people. And that's just kind of one example. But usually what we're doing is we're giving them early access to data. It's going to be available on it's cloud-based access, but they also have the ability to get actual hard drives in some cases, so that if there's a limitation with internet connections, for example, they can still do their job. So, and we can cache certain data. Carriers, for example, are another group that really wants to know what's going on. I mean, they want to know who their insured are in a given area. They want to know how they can best take care of their customers. They want to know where they need to put their cat teams so that they can start taking care of their the folks with policies after an event where a lot of roofs are getting blown off. So it just really varies. But infrastructure, lot of concern with lines and down, and inventorying equipment that might be down, and yeah. So across the board, just lots of variation on that front.
So are these events typical enough that let's say you kind of know well enough beforehand what kind of imagery and tools that they will need, or is it really like case by case and you're kind of figuring it out as it's ongoing and developing?
I'd say that we've been doing this. We've been doing this type of work for over 20 years. So I would love to. I would love to be able to tell you that these things don't happen that frequently. So we're rusty. But unfortunately, you mentioned it before. Regardless of the causation part of the conversation, these types of events are becoming more frequent and they're more severe. Um, Almost nobody will argue that fact, and you've got population growth, so they're definitely more costly as well. So, but the bottom line is that, yeah, we don't know when a hurricane's going to show up and where it's going to show up, but we kind of know how to respond. We know how to respond to them, and there's a set of contingencies: lack of power, lack of access, internet connections, things like that we know how to deal with because we've been doing it for a while. And yeah, we know that between all of the different types of events, you're more than likely going to have something that's going to show up, whether that's an F4, F5 tornado somewhere, terrible hailstorms, a wildfire, volcanoes, earthquakes, you name it. All of these are the types of events that would qualify for that response.
All right, so you mentioned Maui, but to make like a more complete and kind of visual picture in the imagination, could you describe a few specifics, perhaps from a recent disaster that would kind of really, paint the picture of what's happening?
Yeah, I mean, and we get so much feedback from our customers in this respect. But again, a lot of times it's the local government that is the first recipient of this data, and we're getting this feedback that and they're begging for this information. But I mean, even the some of the counties in the Carolinas, you have these roads that are washed out, they're just gone. There's no path to some of these communities, widespread damage due to flooding and whatnot. And just very visually, they're looking at, and I should probably have mentioned this before, but these are areas and these are counties that we're capturing their county. We're flying this in normal conditions, non-disaster conditions. So they have a baseline of, hey, we flew this a year ago, and now this is what it looks like after yesterday. You can easily see the change. We can identify all of those changes, so we can get straight to that user, that dispatcher, and say, hey, look, this used to be a bridge and now the bridge is over here. And visually they can easily get to it and understand what they need to do next. And we get a lot of feedback from our customers to that regard, that has been helpful. That's what kind of drives us.
All right, I think that helped fill out the picture very nicely. So now a little bit for the advice to our engineering audience. How can engineers utilize imagery and drones before and after natural disasters in their work?
Yeah, I think there's probably more ways than I can even detail. One of the things when we're talking to our engineering customers and um, infrastructure folks is I swear they come up with more ways to use our data than I've ever even dreamed of, thought of. Some of what the first thing I would say is that there's a 1 inch oblique image is incredibly high resolution. Most people have probably seen a 3 inch. Not a lot of people fly 1 inch. We're I think the only company that does, and that's about 9x higher resolution than you would get from probably the best available oblique, widely available oblique image. So you can see a lot. And I think that there's a lot of infrastructure folks, engineering folks that are used to going in their workflow, assessing properties, doing inspections, triaging, using some older technologies. I mean, we still hear about people flying helicopters when they're looking at lines, ATVs. You really need to take a look at what the art of the possible is with this type of data, because effectively what we're talking about here is really bringing the field to the desk, and the wealth of things that you can do, even with change detection, understanding how that environment has been shifted due to some type of event or just time itself. There's a lot you can do without necessarily throwing manpower and dispatching people to get in a truck and drive to an asset. So I just say that there's just a tremendous number of use cases here that you should really explore, because the technology's come a long way. And then even with what we're seeing with improvements in AI and all that's available in terms of really extracting information out of this imagery and making it useful, we've come leaps and bounds.
Are there ways that they can use imagery to help make the designs, I guess, more resilient to this kind of damage, or is it still going to rely more on the mathematics and the physics of engineering?
Yeah, I think there is. I think there is. I think that there's certain aspects of the environment. It's going to come down to physics and design, but I do think that understanding the environment and understanding even how that environment's changed over time can help you kind of gut check your design. That's important, especially when you're thinking about things like we've got infrastructure customers that are just trying to they're looking at our imagery over time and trying to manage things like erosion, right? So that's pretty important when you're thinking about capital expense and design and things like that. But yeah, so the answer is yes. I'm sure there's lots of ways to incorporate this basic information into that process. I could probably get schooled by dozens of our customers on exactly how.
Do you feel like there's anything we missed that might be important to our specific engineering audience that you want to include?
Yeah, I would say that we want to hear from you. So we do lots in the infrastructure space and the engineering space, but this is definitely an emerging market for us. So we want to hear from you. We would love to hear how you're using data in your workflows, and frankly, if there's any way we can help create something that would be useful, we'd love to hear it.